take a look at some trig inequalities as well as a trig equation here initially and how we can use Desmos to our advantage to be able to solve that. All right, so if we've got this function here, 2 sine squared x plus sine x, first thing you're going to be is you're going to be at Desmos and you're going to type that in. So 2 sine squared x, and then we'll go ahead and add plus sine x to have our function in there. All right, and it's going to come up and it's going to graph it like this. All right, now that we've got that all typed in, then let's just come up here and look at it like this. Okay, now I don't want numbers like 2, 4, 6, 8 across the bottom. Since this is a trig function, I would really rather have trig values there. So I'm going to come up here to the little toolbar here and check and change some settings on my graph. If I do the capital A there, it just makes it a little bit bolder, makes it easier to read. All right, that's totally optional. Now, what I want is I want radians across this x-axis. So if I go to the step value for the x-axis right there, and then I choose to put in pi, then you can see real quickly that changed. There's negative pi, there's negative 2 pi, there's negative 3 pi. So that changed it to measurements in pi. Okay, now we are going to look at this from just the interval from 0 to 2 pi here. So I've enlarged this. Here's my 2 pi. Here's 0. Now, there's a couple different ways. I could be looking at this on the closed interval from 0 to 2 pi. I could do a half open interval, half closed, closed at 0 and open at 2 pi, a variety of different things. But while I have the actual graph up here, before we switch to paper, let's go ahead and just assume that we were trying to solve this trig equation. All right, well, your solutions are going to be wherever your graph crosses the x-axis. So right there at 0, 0. All right, and then right here at pi 0. Right here at 7 pi over 6, 0. There at 11 pi over 6. All right, and then if I'm only looking, let's say the half open interval, half closed interval, closed at 0, open at 2 pi, I would not include the 2 pi. All right, so I would have 4 solutions, 0, pi, 7 pi over 6, and 11 pi over 6. Okay, so when you're just trying to solve a trig equation, definitely that's one possible way that you could do this. All right, now let's transition to a piece of paper so that we can look at this from an inequality standpoint. All right, here we are with this exact same function. And just to reemphasize what I did there when we were looking at Desmos, if we want to solve this equation on the half open interval with an open interval not including 2 pi there, then we're going to use 0. We're going to use pi. We're going to use the 7 pi over 6 and the 11 pi over 6. All right, so that being our solution of this trig equation in the half open interval from 0 to 2 pi. All right, now let's do this with an inequality. All right, same picture, same graph, but I've changed the question here. Okay, now we want to find where f of x is greater than or equal to 0, again on that half open interval. So I want greater than or equal to 0. So where is the function greater than or equal to 0? So in other words, where is it above the x-axis? Well, the graph is above the x-axis right in here, and it's also above the x-axis on this part right here, okay, if I'm just looking at that interval from 0 to 2 pi. So I'm going to use interval notation to write this answer. This section right here goes from x equals 0 to x equals pi, okay, and it's greater than or equal to, so we'll have our square brackets. All right, interval notation, we'll jump over, we'll get this section that is above the x-axis. That runs for 7 pi over 6 to 11 pi over 6. All right, so on that interval, that half open interval from 0 to 2 pi, then we have 2 little sections there, so our overall answer in interval notation would look like this. Okay, now that's when the function is greater than or equal to 0. All right, could we also do it for when the function is less than or equal to 0? And the answer is yes. So here I'm wanting to find where f of x is less than 0. This time I switched it just a little bit here. I want it on the closed interval from 0 to 2 pi. So that means the point actually there at 2 pi is definitely going to be included. Again, I'm going to use interval notation. This time, where is the function below 0 or below the x-axis? So it's below the x-axis right there, and it's below the x-axis right there. So two very small sections there. But from x equals pi to x equals 7 over pi, that's your first interval. And then because I am on the closed interval and I want less than or equal to 0 and I'm on my closed interval, I can say this little interval right here is from 11 pi over 6 to 2 pi. So again, interval notation, all right, with your union symbol in between there indicating those two solutions, two areas for solution. So the answer would be written in interval notation indicating where that function is less than or equal to 0. All right, so just a way that you can use Desmos for some of those trig inequalities. All right, now the only drawback that I see with using this is even though you set your Desmos to put, pi values along that x-axis and everything, depending on what the original equation is, there could be a time when you click on one of those points and you get a decimal instead of the 7 pi over 6. All right, and if that's the case, you can take that decimal, write it over pi, and then you would have something in terms of pi. But those are just problems that don't work out as nicely when you're trying to look at them from a graphing standpoint and using Desmos, in which case then you would need to actually do those by hand. But this was just quick demonstration here on how you can utilize Desmos for some of your trig inequalities as well as some of your trig equations. Definitely thanks for watching. If the videos are helping, please be sure to share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.